We are the Dirty Burners. We're doing a wireless combustion monitoring project. We're partnered with Constellium, which is an international aluminum manufacturer. We're partnering with their plant in Ravenwoods, West Virginia. You can see here we have a little presentation or a little poster provided by them for us for this presentation. So the gist of our system is they have these industrial furnaces, and these industrial furnaces are used for annealing processes. Currently, the furnaces don't have any way to monitor their oxygen and the excess oxygen in the flue gas, and so we've developed a system to do so. So the way our system works is there's burners on these furnaces. There's 16 per furnace. Each one of those burners gets one module that we've made, which right here you can see. And those modules can control a sensor that actually monitors the oxygen levels. And so this data is collected by us, and we send it over to a plant network so they can have a log of their data, and we also send it to a tuning device so they can tune the air-fuel ratio in real time. And that's what we're trying to solve, is these furnaces a lot of them are out of tune and they're burning not very efficiently. And so we're trying to provide them a way to see what oxygen levels are like in the flue gas, and so they can tune it to the correct levels so they can burn efficiently.
So you may ask why you care about excess oxygen. So basically that's a main constituent in the combustion process, or in any combustion process, in a car engine or a wood stove or propane or any natural gas combustion system. So what you put in is air and fuel, and you get out CO2 and heat and a little bit of air that's left over. So what we're monitoring is excess air, because that's very determinant in the efficiency of the entire system. As you can see here, I have some graphs that show how much you can save based on your excess O2 and temperature of the flue gas. So right here is where we're landing with our current customer, and we can save them around $30,000 annually just on fuel savings. And we can also reduce their carbon CO2 output by about 500 tons per year, which is the equivalent of about 100 North American cars. That's annual savings by fuel reduction. And then
so here we have some of our custom built electronics. There's two blanks here. They haven't been populated with parts. And then here's our monitoring panel, which is this module that is populated. So we've designed and built all of these ourselves. This is the monitoring panel module. This is what communicates with the sensor, takes in excess oxygen, and communicates to the controller here, named the Ethernet panel. And everything is done wirelessly through LoRa, which is a wireless communication protocol.
Okay, so here's the Ethernet panel. This acts as the brain of the entire system here. It will ping each monitoring panel to request the current data, and after it receives that data, it will be transmitted through Ethernet to the plant network. This can be used to have an overall trend line of all the data, while also storing locally on the Ethernet panel for further observation later on.
Yeah, so this is our tuning device. As you can see, our company logo on there. This has 3 screens. This first screen here is a multi-furnace screen, so basically being able to show all the data for all furnaces that Constellium has. Then we can click on any one of these, for example, furnace 11. That's what we actually implemented on. And we can see we have 4 red squares there, since all these are currently reading open air. This basically tells the operator if it's red, it needs to be tuned, and we can go through and tune that burner, so we can even go one level deeper into a single burner, and that's where we can start to see a trend line and really see how the data is moving. And this burner right here is actually what's connected to the smokestack right now, and we'll be able to see that it's at roughly 9% excess O2. So if we go and tune this, we can see it kind of gets closer, and you see a color gradient there. as you get closer to 3% excess oxygen, which is the goal.
Like he was saying, this is kind of like our demo. This is acting as the flue pipe that our oxygen sensor will actually go into at the plant. And then it'll come to the monitoring panel that Garrett was talking about. And then this will send the signal out to the Ethernet panel that it'll split into the plant network that's shown on the laptop and then to the tuning device that operators there will be able to hand hold and go adjust the oxygen on the bottom of the furnaces. So